what storage portfolios we have within AWS. We have three storage portfolios. We have block storage, we have file storage, and we have object storage. Block storage is like your hard disk drive, either SSD or HDD. It allows you to create a file system and then store your data in, but it's mainly dedicated for a single EC2 instance. And then you have file storage. File storage is useful when you have multiple EC2 instances and even connecting from on-premises and other applications that wants to utilize the shared storage. Object storage is when you want to store objects. Could be images, videos, documents. So you're treating all of those as objects that needs to be stored in object storage. Let's dive into block storage in more details and talk about what exactly is that. Block storage within AWS is divided into two. We have Instant Store and we have Amazon EBS or Elastic Block Store. What are those exactly and what are the differences? When you create a new EC2 instance, you always need to assign a block storage, which is going to be formatted and used for your operating system. You can further add other block devices or other SSD disk or HDD disk so that you can have more storage for maybe other applications that you may be running in your environment. Instant Store is the hard drive that is within the physical server that then gets given to you to utilize. Whereas Amazon Elastic Block Store is an external storage device that your instances have access to. Okay? Maybe let me try and explain that in a different manner on the whiteboard here. So within the data center of AWS, we have a rack. A rack is a tall structure like a fridge where you slot in or add servers or physical servers into. So this is a rack of mine. Within this rack, I can then have a physical server. So there is a physical server there. Within the physical server, I then create virtual machines, as you now know as EC2 instances. But here's something that we never really talk about a lot, is that each of these physical servers also have a disk inside. This disk is like your SSD disk that is available there. That is within the physical server. So when you create a new EC2 instance, you have a chance of actually taking over that physical server. But what we've been doing recently has always been about creating a VM that does not have a disk inside. So how did we then have our operating system get installed? Well, we used what is called Elastic Block Store, EBS, which is like your SAN storage. Think of this as an external storage device that has many disks inside that, of course, are working together to allow you to create that EBS volume. So you then create maybe, let's say you're creating an EC2 instance, you create an 8 gigabyte volume from the EBS service. Now that gets attached into your VM like we did before, and this VM has now this disk, which is 8 gigabyte attached to it, and we're running operating system there. For other VMs, it's possible to use the EBS volume as one of the disks inside, and also the instant store. The instant store is now the physical disk that is actually within the physical server. What's powerful about that instant store is that it is very, very fast because you're talking to the disk that is right there anyway. While EBS, it's outside of your physical server, but although still connected by fiber cables to make it fast, is not as fast as Instant Store. However, there are a lot of other benefits of EBS volume, such as being able to take snapshot. A snapshot is a point-in-time backup of a volume, which means you can be able to recreate the volume exactly as it was when you took the snapshot. With Instant Store, you cannot take a snapshot. And of course, with Instant Store, you also cannot increase the volume because you are given that volume size exactly as it is. If it's 32 gigabyte or 160 gigabyte, it's exactly like that. You can, of course, concatenate many different volume or many different disks if they are available there. But if not, you are limited to that space. With EBS, you can actually extend the size of your EBS volume that you have created before. When you look at what really makes up this EBS volume at the back end, we have SSDs. Those are solid state drives. A solid state drive is like a USB. It has nothing spinning inside. Everything is just static, solid components that do not move. Of course, you can move it by making it fall and it breaks and it doesn't work anymore, right? But nothing moves inside. And then we have the hard disk drive, which is what many of us know and are aware of, where there is something spinning inside. You tend to see this nowadays on your external drive. If you listen to it carefully, you can hear something spinning, especially when you are interacting with it, like writing or reading. Solid state drives are very good for high performance. They're designed for that. Whereas hard disk drives are good for high throughput, for something that is streaming continuously for a very long time, right? Because they spin over 15,000 revolutions per minute, right? So you get to have that guaranteed throughput for a very, very long time. But faster interaction to the disk, like reading, writing, SSDs are much better for that. So where exactly do you find this Amazon EBS? So if we go back to the demo account of mine here, let's go to EC2 service where we have EC2 instances. By the way, EBS is right within the Amazon EC2 service. You might remember that I had a demo VM earlier on that I deleted. I just recently created another one here, demo VM2. Exactly the same spec and everything. So this VM2 under storage, it has, of course, a single EBS volume that is used for the operating system. It's possible to attach more by, of course, going to the EBS service. Just on the left here, on the middle side, we have EBS. So with EBS, you can create volumes that can now be attached to particular EC2 instances. And then, of course, you can expand or grow that particular volume if you wanted to. Here is something you need to remember all the time, is that when you have an EC2 instance that you are running and you now want to attach an EBS volume to that instance, the EBS volume you are creating and the EC2 instance must be on the same availability zone, else you won't be able to attach the volume to the instance. One way to know where the instance is in terms of availability zones is to look at the previously assigned volumes, where they are. In this one, US West 2A. You could also just go straight to the EC2 instance and just check it there, which I will recommend you do because volumes can be a lot and you might miss exactly which one belongs to what instance. So this instance is on US West 2A. So if I had to create a volume and I want to attach that volume on that instance, it will also have to be on the same availability zone. Okay, let's maybe try something like that. Let's create a new volume here, and this volume is going to be on the same availability zone. I'm going to use GP3, 100 gigabyte, I think is fine, and US was 2A. Be careful about that because it needs to be on the same AZ as the EC2 instance you want to assign to. Let's put a name here of this volume. Let me just call it my volume, and then create this EBS volume, which is 100 gigabyte. Once created, it's going to be available there. But if you look under volume state, it's available, is not in use or not assigned to anybody as yet. So let's go to my EC2 instance and then log into it. I'm going to use a session manager for this to hop into the EC2 instance so that you can be able to see what volumes are actually in that instance. This, by the way, is a secure way of connecting to a particular instance via SSH. It's secure because there is no need for SSH key pair to be attached to an instance, and also you do not need to have port 22 opened on the firewall. So this is by far the most secure way of logging into the instance. We call it Session Manager. I'm now in the instance. If I run lsblk, which is list block devices, by the way, this is a Linux command, I get to see that I have just one volume, which is 8 gigabyte. You will remember this is one for operating system. And I have a couple of other partitions. Partitions are like a way of carving out the disk into smaller chunks. But I don't care much about those partitions because I'm looking at the disk here. So let's assign a new disk into that particular instance. So I'm going to go to EBS and take the one we just created now. Make sure it is checked, the checkbox there. And then attach this volume onto a particular instance. Now, this is where you need to make sure that your instance was indeed on the correct availability zone. Because it's Linux, I'm also going to just add a drive letter as a way for knowing which disk is that inside the operating system. Once attached, you're going to see it is now in use. So technically, if I go back to my machine here and then run lsblk again to list the block devices, I should now be able to see that, wow, I have a 100 gigabyte extra volume created now or attached to this machine. In the future, if this volume of mine, after formatting it and mounting it into a particular mount point, I'm adding lots and lot of data, it becomes small. I can go back and say this volume must now be changed, modify volume to a bigger size. Like let's say from 100 to now 500 gigabyte in size. Modify, make sure you know what you're doing, and click modify the volume. It takes a couple of minutes or so, also depending how big the volume is, to then add other blocks to make it bigger. So after some time, if you go back to your machine and run lsblk, you should now be able to see that the volume I have is now 500 gigabytes, is no longer 100. Can I make it smaller? Technically, it's possible to make it smaller. However, AWS does not recommend you to do that, so we just do not give you an option to do that. Why is that the case? It is the case because when you are using a disk, I'm just going to throw it as a long line, and then you are adding data into that, and you are deleting data, you adding more data, deleting data, you adding more data, deleting data. So we may not know exactly where your data is, because when you are resizing, you are working from the SAN storage side. You don't get to see the blocks in the volume where the data is. So shrinking the volume to like half the size can cause corruption because other blocks of your data will be lost. And if you lose any block that is part of a particular file, the whole entire file is corrupt, or technically the whole block, the whole volume is corrupt. You cannot use it again. So because of that, AWS does not allow you to shrink a volume. So if you try and shrink a volume, it will not be permitted. Like right now, it's about 500 gigabytes. So if you try and make it smaller, it says, sorry, can only be increased only, not decreased. Okay, so that is Amazon Elastic Block Store and also Instant Store. You might be wondering, how do I know if I have an Instant Store for the VM I'm creating? During the creation of the VM, when you are choosing the instance type, just write, where is that? I think I went too far. Instance type here. You can compare instance types and look at the ones that have a disk inside the physical server. So if you check here, most of these that you can see, they don't have any. But as you scroll down, you start to see some numbers showing up. This one has a volume which is 350 gigabyte, and it's an HDD, which means it's a spinning disk. Sometimes we call it a rotating rust, right? And other ones have SSD disk, so on and so forth, and you get to see the size of them as well. Okay, that is called the Instant Store. It's also form part of the block devices as well. Moving right along, let's look at file storage. All what we just spoke about now is a disk assigned to only one EC2 instance. What if you have more than one EC2 instance that wants to communicate over a shared storage? Maybe different instances on many availability zones, and even on premises or other applications. Now that is where you require a shared file system. We call it file storage. In this example, we have Amazon EFS. Amazon EFS is very similar setup to your normal NFS or Network File Share version 4. So if you come from on-premises, you might be familiar with Network File Share. If you want to share folders with different Linux or Unix machines, you tend to use NFS. So Amazon EFS is exactly the same setup, that allowing you to have this central file storage for many different machines that can communicate and talk to each other over the data. But what if you have maybe other types of workloads, like Windows type of workloads, or perhaps maybe you have HPC type of workload, high parallel computing type of workloads? Well, we have another one called Amazon FSx. So Amazon FSx comes in with different flavors like NetApp, ONTAP, OpenZFS. So if you somebody who comes from Oracle Solaris from many days when you used to have Z-pools and ZFS file systems, so Amazon FSx comes with that similar storage setup. You have Windows file server as well. If you are somebody who used to share folders and files on a Windows computer, if you right click and share, you can even specify who you're sharing it to, and somebody wants to see your files using / and your IP address and then your share name, that is called Windows File Share. So it also offers this as well. And of course we have Lustre. So Lustre is for that HPC type of workload, high computing type of use cases. Maybe you are doing parallel reads and writes to a shared or central file system. So Lustre is the best one for you. Okay, and then lastly, let's talk about object storage. What exactly is object storage? Object storage is when we are treating our files as object, not as blocks anymore. So you treat a file as a single unit. Should you need to modify that shared file, you need to re-upload the whole entire file again. It could be images, videos, documents, so on and so forth. And even 0-byte object is also considered an object as well. This object will have data that symbolizes the object itself. Will have metadata, which is data about your object, like the date it was stored, the encryption, if it has one or not. Some of those are system generated, like if it has encryption or not. Other ones can be user defined metadata, like what team name does this file belong to, what cost center number, so on and so forth. And then you have the key, which is the name of the file that you are now storing. Within AWS, we have a service that is designed exactly for that. That is Amazon S3, or Simple Storage Service. It allows you to store objects. You can have name of those objects. It must be unique, of course, within a particular prefix or folder. For you to work with Amazon S3, you need to choose a region where you are going to create your Amazon S3 bucket. But here's a very interesting one about Amazon S3, is that even if you have chosen a region, the name of the bucket must be globally unique. You cannot have the two buckets with exactly the same name, even if they are on different regions. One of the most fascinating ones there. Amazon S3 is virtually unlimited in terms of storage. The only limit you have is that each file can never exceed 5 terabytes of size, just a single file. But beyond that, it is virtually unlimited, and it's pure serverless as well. About security, well, everything, as you'll remember, it starts from IAM. Are you allowing somebody to actually work with S3, yes or no? If no, do not attach any IAM policies that will allow the user, the group, or the role to talk to S3. We didn't speak about this one before. Amazon S3 has something called a resource-based policy. A resource-based policy is like an IAM policy, but it doesn't reside in the IAM service. It resides within the resource itself. Like in this case, a bucket policy will be a policy attached to Amazon S3 that governs access on who can talk to the Amazon S3 bucket. By default, when you create an Amazon S3 bucket, it blocks public access. In the past, we used to have issues within AWS where customers create a bucket, they start storing sensitive information, and forget to make the bucket private. So now, every bucket you create by default, it blocks public access. And also, all of the objects in the bucket, they are private by default. So which means if you want to make your object publicly accessible, you can remove the block public access and also make your objects publicly accessible by setting up the bucket policy. The encryption of your object inside Amazon S3 is there by default. You can choose to change the encryption key. So server-side encryption by default is there. You can choose which encryption key you want. You can also configure client-side encryption. This just means that when you send a file to Amazon S3, the file is sent already encrypted because it is encrypted on the client side. Whereas the server-side encryption means that the file is sent in an unencrypted or plain text manner. Then in the server side, like S3, we then encrypt it. Okay? Whenever you use Amazon S3, definitely you want your object to be available now when you want it. When you want your objects. I think it's a fair case. And for that to happen, AWS must have infrastructure underneath to keep your files warm all the time. So that when you want your file, in just milliseconds, your file is with you. Well, depending on how big the file is. Gonna take some time to download, but you have access to it. Well, that means all of the files you are going to store inside Amazon S3, they will have a class called Amazon S3 Standard. This class means all of your files are warm, and it's a default class or storage class for Amazon S3. What if you want to save cost? Because your files are going to be infrequently accessed. Well, you can choose another class for your object called Amazon S3 Standard Infrequently Accessed. This means AWS does not have to keep your files warm they can be somehow lukewarm, but not too cold. So when you request a file, it will take a couple of milliseconds before you get it, right? Because we consider it infrequently accessed. But of course, you still get it, still fast. And many customers who use infrequently accessed, they never get to see the difference. Let's say you are dealing with files that can be reproduced. How can you go about saving cost on those reproducible files? Remember when we started, we said there is a region. The region requires a minimum of 3 availability zones. One of the reasons for that number of availability zones is so that services such as Amazon S3 can redundantly store the data within 3 or more availability zones so that your files are stored and they're not deleted. We call that durability. Okay? S3 has 11.9 durability, which means you can literally never lose a file unless you delete it. But what if I'm dealing with reproducible files that can be deleted and I can reproduce them again? Well, you can take advantage of Amazon S3 one zone infrequently accessed, which means instead of 3 availability zones, we are just using 1 availability zone. It's technically risky because your files can be lost, but here's a great thing. We have never lost an availability zone since the birth of AWS until now. We've had some glitches, but files were never lost to a point of like permanent deletion, which means if you were using one zone, you could have been saving a lot of money. But of course, it's not about saving money. It's about looking at the use case and how critical the workloads that you're dealing with. That's actually the decider. What if I want to store files for many, many years? Well, I can use Amazon S3 Glacier. We have Amazon S3 Glacier and Amazon S3 Glacier Deep Archive. Glacier is divided into 2. We have instant retrieval and flexible retrieval. So which means you can store your data, but you can have that flexible retrieval of your data whenever you want it back. We charge you a lot of money when you want your data back because this storage is designed for storing or archival for many years. Deep Archive, it's if we are talking about over 15, 20, 30 years of your files, you want them to be stored there. That's Deep Archive. There are times when you are dealing with massive amount of data that needs to be stored, but you want to save cost. So it needs to be standard, but when it's not being accessed frequently, it needs to be on infrequently accessed. And if it goes maybe beyond 30 days, you want it to be on the archival solution. You have to do that manually all the time, but think about if you have petabyte scale data. You can save a lot of cost if you can have somebody to automatically move your data between different classes. Well, that is what we mean by S3 intelligent tiering. It can automatically move your data between different tiers based on the access pattern of your data. So it uses AI and machine learning to understand your access pattern. Then based on that, it's going to move your data into the correct class. And if you no longer use the data, it then moves again in different classes to help you save cost. Here's the last interesting feature of S3 to share with you before we end this module. Amazon S3 versioning. If you come from a development background, you might be familiar with code repositories where you can have different versions of your source code, so on and so forth. Amazon S3 has a similar concept as well, where a file is never deleted, but rather a new one is then presented to whoever is looking for the file. What's interesting is the older file is still existing, no matter what you do. But of course, you are liable to pay for all of those costs as well. Here's an example here. Versioning is not enabled by default. You need to enable it. Once enabled, it can never be disabled, but it can be suspended. Once enabled, it can only be suspended. So I'm storing a new photo here, photo.gif. It then gives me a version ID, 111111. I then overwrite that photo with a new one, exactly the same name, in the same bucket. I then get a new version 12.12.12, the version ID. So what I've just done here is I didn't just delete the old file or replace it altogether, but both files exist simultaneously. If I want to talk to the old file, I can just pass through a version ID of the file that I'm actually looking for. Let me just show you S3 on a high level. With Amazon S3, remember that your bucket must be within a particular region. So you choose a region, but the name of the bucket must be globally unique. So let's go on and create a bucket here. I'm going to leave it as general purpose. There is another one now called directory for other use cases. Let's call it test bucket. You might, of course, think that name has been taken, but let's see if that name was taken or not. There are other configurations you can do. By default, as mentioned, it blocks public access. You can remove this if you want to, and only do that if you know what you're doing, because your bucket will now be publicly accessible. Versioning is disabled by default. You can enable it if you want to. There's encryption by default. You can choose what key you want to use for encryption. If you don't choose any key, a standard one will be managed by Amazon S3 for you. Let's go ahead and create this bucket. And of course, it doesn't go ahead. It's failing because the bucket name is not globally unique. So let's make it unique by putting some numbers there, like characters, and then try again and create that bucket. Okay, looks like it's going ahead now to create the bucket. So after some time, I should have a bucket created if, of course, everything went well. Yes, the bucket now is there, test bucket. This is what we mean by object storage. Within here, I can now store objects inside. That's what we mean. We have features such as block public access and bucket policy to control the access into the resources or your object you store inside your bucket. And of course, there are many other features that you can also deal with Amazon S3, like versioning, encryption, intelligent tiering configuration. You also have this interesting one here called event notification, where if you store an object inside S3, it will trigger other events like Lambda. It will trigger Lambda, a function, and send the event. Then you can use Lambda to maybe crop an image or summarize a document. Very interesting other use cases there. It's called event notification. Cool. That's what I had for you on Amazon S3 or just storage in general.